Good morning one and all. In previous lecture, we learned about FPGA architecture, features and specifications of FPGA. Today, we will learn about different types of simulation and synthesis tool available for programmable logic devices and what is meant by FPGA synthesis and implementation. There are different types of synthesis and simulation tools which are used for programming the PLD. The synthesis, as we learn about, the synthesis is a process which converts the RTL or SDL code into the netlist. Hence, the different tools are available for synthesis process like FPGA Express, Xilinx synthesis tool, Leonardo Spectrum, Simplify and Mentor Graphics. You can use any tool as per your convenience or availability in your lab. The synthesis process generates the netlist and which is downloaded on your hardware so that the required interconnection between the signals are made on the board. Similarly, simulation also is an important process which verifies the functionality of your program or your design. And before implementation of your code on hardware, simulation is necessary. Hence, again, there are different simulation tools available in the market like Xilinx IC, Altera Quarter Second, Model C, Active SDL, Cadence, Altium. You can use the tools which is available with you. Generally, most popular tools are Xilinx, Altera and Cadence. Altium is most probably again used. And synthesis tool like Mentor Graphics, Xilinx and Leonardo Spectrum. Now, as in previous lecture, we learn about architecture of FPGA, but what exactly happens in the FPGA synthesis process and what is the design implementation in the FPGA programming. Now, this is the FPGA design flow. The FPGA design flow is similar to your normal PLD design flow, except some conditions. Now, first of all, you have to plan and budget for your project. Then you have to write a code or generate a schematic. Then you have to perform the RTL simulation process. Then perform the synthesis process to create the netlist. Then perform the functional simulation of your main code to check whether expected outcome and generated outcome will match. The most important is implementation process, which consists of different processes like translation, mapping and placement and routings. And once implementation is completed, you have to attain the timing closure to check the performance of your system in terms of delay. Then perform the timing simulation to generate the timing reports to see whether your system will attain the performance as per the customer requirement. And finally, generate the bit file, and that bit file will be downloaded via the programming cables into your system hardware. Now let's talk about the FPGA synthesis. Already we discussed about this, but let's summarize what is the FPGA synthesis process. In FPGA synthesis, it creates the representation of system at lower level of design abstraction from the higher level of representation. Now here, high level representation in terms of either schematic or SDL code, and lower level in terms of netlist, which consists of signals and their interconnections which is required to do on your hardware or PLD. This process converts your SDL code into the gate level netlist. Hence, we can use the different synthesis tool. For FPGA synthesis, we can use most probably Xilinx synthesis tool and Mentor Graphics tools. These are very popular tools. Nowadays, again, Altera Quartus is also popular. The netlist, as we know that the output of synthesis process is netlist. The netlist consists of the description of logical cells which are used on your FPGA and their interconnections. The netlist formats are available in the different types like EDIF, Electronic Design Interchange format, vendor specific format, and the Xilinx netlist format. Here EDIF, this is a vendor specific format. Generally the Xilinx tool produces XNF format, and that is most probably used for generation of netlist. The synthesis process consists of different steps like translation, optimization and mapping. Already we discussed about this in the design flow. The translation is a process which converts your HDL code or RTL description into the Boolean unoptimized description. Means whatever the diagram or HDL code, from that it will obtain the Boolean equation. It will extract the Boolean equations by using the operators by using the operators symbols which we are used in your main HDL code. Once the Boolean equation, an optimized Boolean equation is generated, then second step is optimize that Boolean equation using various algorithms. Means it converts your unoptimized Boolean description into the PLA format, and it consists of the two processes, flattening and factoring. Already we discussed this process in unit number 1. Then mapping. Mapping is a process which maps your optimized Boolean description to the technology specific component from the library. This is about the FPGA synthesis, and synthesis process is very much important, and what tool you are using again important, because its output generate the optimized netlist, and that optimized netlist reduces your hardware which are implemented on your board. The next process, once synthesis process is done, then you have to perform the design implementation. As netlist is generated, we can implement our design, and that implementation of design consists of again different steps like translation, mapping, placement and routing. In translation, it will merge multiple files which are generated by the synthesis process into a single netlist. Then in mapping, it will group your all logical symbols from the netlist, which is input to this process, into the physical components like slices and IOB. Means it will group the similar components from the netlist and make a group. Then next is placement and routing. Then in placement and routing, it uses different placement and routing algorithms to place component on the chip, then to connect that component and extract timing data into the reports. And once this implementation process is completed, different reports are generated. Means output of this implementation process consists of different reports, some timing simulation netlist, some floor planning files, then FPGA editor files and many more. Hence, each phase in this implementation process allows the tools like Xilinx tool, and for that purpose we can use the different tools like floor planner, then FPGA editors, XPower. Floor panel is used for placement and routing purpose. Then XPower is used to generate the power or to calculate the power which is used by that components. And FPGA editor is used for generating the different component files of this implementation process. This is about the design implementation, means FPGA design implementation. Hence, FPGA synthesis and design implementation is very much important part in the FPGA design flow. Hence, in today's lecture, we learn about the two topics like what are the different simulation and synthesis tools are present for PLD as well as for CPLD and FPGA. And second important point, what is the FPGA synthesis and simulation process.